Hey there guys, Mr. Carlson here. Let's talk about electronegativity. In the previous video, we were discussing this thing called ionization energy, which is basically the amount of energy that we need to remove an electron from an atom to make it a positive ion. So for like lithium, for example, it would take 8.64 times 10 to the 19 joules. It would take that much energy in order to remove that electron from lithium and to make it a positive ion of Li plus 1, lithium plus 1. And we said that we can think of ionization energy as how strongly an atom's nucleus holds on to its valence electrons. So for lithium, for example, it's got a rather low ionization energy, and so it really doesn't have a really strong hold on that one valence electron, so it easily gives it up. But then there are some elements, like the nonmetals, where they have a really high ionization energy, and so they really have a strong hold on their electrons. Now, today what we're going to talk about is in relation to this, is that so the way that these electrons get removed is from other elements essentially. So like if lithium comes into contact with something that has a really strong pull, it will be able to pull that electron away. And so that's what electronegativity is looking at. It's really kind of like the opposite of ionization energy. It's the ability of an element to attract electrons in a chemical bond. And as we're going to find out, is that there are some elements on the periodic table that are very, very electronegative. They have a really good ability, or they have a really strong attraction of taking electrons from other elements, or holding on to other electrons from other elements. And then there are some that aren't very electronegative, and they don't really hold on to their electrons very well, kind of like lithium, for example. Doesn't really have a strong attraction to their electrons, but some do. And so the trends that we see with electronegativity are that generally the amount of electronegativity decreases as you move down a group. So starting at the top of a group and moving our way down, how electronegative those elements are kind of decreases, and it increases as you move from left to right across a period. So if we look at this this periodic table here, this periodic table is showing just the electronegativities. So in red, things that are in yellow and red, those elements, oranges and reds I should say, those elements have a very high electronegativity, meaning that those elements are very good at taking electrons. So they have a very strong attraction for those electrons. But then things that are more kind of in this greenish color are a low electronegativity, and they don't really have a very strong attraction to taking electrons from other elements. And so again, the general trend that we see here is that as we kind of move up in this way, diagonally, if we move up towards this corner, fluorine being the most electronegative, oxygen and chlorine as well, and then the least electronegative would be kind of down here in this left-hand corner, things like francium, cesium, barium, radium. These are the least electronegative. So these really don't take electrons. They are very prone to giving electrons away, as we learned yesterday. And these guys over here are like the opposite of that. They aren't very prone to giving up electrons. They're very prone to taking electrons. And so that's the pattern that we see here, is that as we pick like the second period here and we move across this period, we'll notice what's the pattern is that we increase in electronegativity. And that's the general trend for each period. So period 3, as we move across this period, we start to increase. Same thing for period 4. Again, there's some exceptions, right? There are usually typically kind of with these transition elements and things like that. There's a few exceptions, but the general trend is that as I move from left to right across a period, I will increase my electronegativity, or the ability to take electrons. And then if I move down a group, so starting with group 1 and 2, if I move down a group, I will decrease my electronegativity. So towards the top of a group, these elements are a little more electronegative, and as I move down, they get less and less electronegative. So if I come over here to maybe group 17, we'll see that, right? Very high electronegativity. As I move down, they get less and less electronegative. They get less and less of that attraction of electrons. Notice, by the way, that a lot of the noble gases, it says no data, no data, no data. Krypton and xenon do. They can sometimes form bonds, but radon, no data. That's because, remember, the noble gases, as we keep repeating over and over again, these guys do not really bond with anything. Krypton and xenon will bond with a few things, and so there's a little bit of data there. But for the most part, these noble gases, they don't bond with anything, and so they don't need to take electrons, and they don't need to give up electrons. And so that's why these ones, there's really nothing, there's nothing to be said about these guys, really, because they don't bond with anything anyways. Now, so that's another trend in the periodic table that we've been talking about. We've talked about like 4 different trends, and so what I want to do is take a second and make sure we understand all the different trends that we've talked about so far. If we look at what I've got down here, just to zoom out a bit, I've got the things that we've learned so far. Here's my outline of the periodic table, and here are the general trends that we've so far learned about in this section. We've learned about atomic radius. Remember, atomic radius was the size of the atoms, the sizes of the atoms. And so we saw the general trends for that is as I move across a group this way, that the trend is that the atomic radius gets bigger, so it increases. As I move this way across a group, a period, as I move this way across a period, but as I move down a group, the atomic radius decreases. Then we learned about ionic radius. So for an ion, so in other words, once it either gains or loses electrons, and we saw that the metals over here on the left are the ones that are giving up electrons typically, and the elements over here, those nonmetals, are typically the ones taking electrons. And so what we see is that in general, the ionic radius decreases as I move across this way, and it generally increases as I move down a group going this way. Ionization energy we talked about just yesterday. Ionization energy was, remember how tightly it holds on to those electrons that it already has, and so we saw that the ionization energy increases moving from left to right. So as I move across a group this way, those elements that I get further and further over here, they have a really tight hold on their electrons. And as I move down a group this way, they get less and less of a hold on their electrons. And then today we learned about electronegativity. And we see that as we move across a group this way, that electronegativity increases. And as I move this way, that electronegativity decreases. Again, these two things kind of being very related to each other and how they either hold on to their electrons or how they give up their electrons. So hopefully this is a good overview of the things that we've been talking about this week.